I welcome you all to Sylas Academy. This is my channel. And in today's video, I'm going to be teaching about complex numbers. Are you following now? I'm going to be talking about complex number. What are complex numbers? We say complex numbers are numbers that has two parts, which are what? The imaginary part and what? The real part. There are numbers that have what? Real part. In expression, is being expressed as what? Z equals what? A plus BI. Are you following now? A plus BI. These A are what? Integers. B is what? Imaginary numbers. The integers are also called what? The real part. Are you following now? Let's say A equal to what? The real part, and BI is what? The imaginary part. Are you following now? The BI is what? The imaginary part. How is BI imaginary part? Because of what? This I beside the B. Are you following now? It's called what? Imaginary part. That is just the definition of complex number. Next, we are going to be looking at what? The arithmetics of complex numbers. The arithmetics of complex numbers. Now, I used to tell my students that what arithmetics normally is a very simple thing. Arithmetics deals with four guys, which are what? The addition, subtraction, multiplication, and what? Addition. And these four guys made up to build what? The arithmetics of complex number. What are they? Number one, we have the addition. Number two, we have the subtraction. Number three, we have the multiplication. Number four, we have the division. These are the four guys that made up what? Arithmetics of complex numbers. Now, we are going to what? Simplify them one after the other by what? Taking their example. Now, let's start with the addition of complex numbers. Addition of complex numbers. Now, in addition of complex numbers, how do you add complex numbers? Before I proceed, okay, at the end of the class, I'm going to tell you one very important thing. So go follow. How do you add complex numbers? Now, we have verified that complex number is being given by this expression. And so therefore, it has two parts, which is the real part and imaginary part. Are you following now? So in addition of complex numbers, now it's being given like this. Okay. In addition of complex numbers, add the real part, differently, and add the imaginary part. Imaginary part differently. How does this statement works? I've been given an example that minus 3 plus 4i plus 2 plus 2i. How can you solve this addition of complex number? Of course, it's an addition because the middle sign here shows that what is addition. So how can you solve it? Using this statement, they say that what in addition of complex numbers, you add the real part different and imaginary part different. Now, This is what? Your real part. Are you following now? That has only a or only a magnitude or number. Now, coming to the imaginary part, it has what? Bi. That's to say that what? Wherever you see 3 here, singly means what? It represents a real part. Are you following now? When you see 4i, it means what? Is what? An imaginary part. Abina. Now let's say since you have said that the 3 and 2 are your imaginary parts, you write your solution. Okay, now let me make it so simpler. This will be your real part and what? Your imaginary part. Let's say add the real part and imaginary part differently. This is your real part. I want to know that the real part is what? 3 and 2. So I'm going to say 3 plus 2 plus this what? Your 4i, which is the imaginary part, and 2i. That is 4i plus what? 2i. If they add them together, this plus this gives you what? 5. This one plus this one gives you what? 6i. That's to say what? Your solution for this thing becomes what? 5 plus what? 6i. And this becomes what? Your solution for what? This question. Are you following now? Okay. Let's go for the second one, which is the subtraction of complex numbers. Okay, now, in subtraction of complex numbers, you know that subtraction is the opposite of addition. Are you following now? Subtraction is the opposite of addition. So whatsoever you do in addition of complex number, you are going to do the opposite in subtraction of what? Complex number. How do you do the opposite? Now, let's solve this question now. Okay, let me give you this statement. Just do the opposite of what you did in addition of in addition of complex numbers. Now, what is the opposite of what you did? They give you this question, say evaluate 3 plus 4i minus, because minus is the opposite of what? Plus, into 2 plus 2i. Your solution is here. Say do the opposite of what you did in addition. I'm going to say 3 here, that is 3 minus 2. In plus, in addition, we are adding them. Are you following now? That is addition plus minus 4i minus what? 2i. Are you following now? Subtract them. This one minus this one will give you what? 1 minus 4 here minus 2 gives you what? 2. And this is your final answer. Are you following now? You have what? Your real part and what? Imaginary part. Okay. Now let's go for the subtraction, multiplication of complex numbers. Now, you all know that in multiplication is very simple. Are you following now? Multiplication in complex number comprises of two brackets. Just open the bracket, simplify, and then you get your final answer. Now let's take this example again. Evaluate 3 plus 4i into what? 2 plus 2i. This what? Multiplication. Because the bracket are what? Backing itself without any sign in between them. Write your solution. Having something like this, what are you going to do? You express your question. How do you express your question? 3 plus 4i into 2 plus 2i. This expression of your question. Are you following now? So now you open the bracket. 3 here. This 3 times 2 gives you 6. Plus 3 times 2i gives you what? 6i. Plus 4 here times 2 gives you what? 8i. Plus this 2 here, this 4 here, multiply this one gives you what? 8i squared. This one times this one gives you this. 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 Are you following now? So next we are going to what? Simplify. How do you simplify this? You have like terms here. What do? You collect the like terms by saying 6 plus this 6i plus 8i here are like terms. Bring them together. 8 plus 6 will give you what? Is 10. It will give you 14. You have 14i plus what? 8i squared. But if you follow my first class on complex number, I told you something that I squared means what? Minus 1. You remember? I squared means what? Minus 1. I used to say anywhere you see I squared, you replace it with minus 1. I'm going to say 6 plus 14i plus what? 8 into what? Minus 1. Are you following now? When you open the bracket, I'm going to say 6 plus 14i minus 8. That is minus times plus gives you minus. Are you following now? Then 8 times 1 gives you what? 8. Next, you collect your like terms here. In collecting your like terms, 6 here and 8 are like terms because they have no coefficient. Are you following now? So 6 minus 8 will give you what? Minus 2. Are you following now? 6 minus 8 gives you minus 2. Then plus what? 14 plus 14i, and this becomes what? Your final answer. Are you following now? Now let's solve for the last one, which is the division of complex numbers. Division of complex numbers. Now in division of complex number, when you have equation like this, 3 plus 4i all over what? 2 plus I. Now, this what a equation under what? Division of complex number. Because of what? This line are cut across what? The numerator and the denominator. Evaluate this question. How do you evaluate this type of question or solve question under division in complex numbers? Now, in complex number, you are going to take the conjugate of what? The denominator, multiply it by the numerator and the denominator itself. How does that work? You have a solution. 3 plus 4i all over what? 2 plus I. Now, what will you do? Take the conjugate of the denominator, multiply it by its what? The numerator and the denominator itself. First of all, what is conjugate? Now, for you to solve division of complex number, you must not what? Rationalize. Are you following now? Now, this conjugate, changing what? Changing the middle sign of a given question. Okay, now these are question. Are you following now? They say 2 plus what? I. How can we take the conjugate of this thing? Just what? Changing the middle sign by minus. Are you following now? So therefore, the conjugate of 2 plus I is what? 2 minus I. Let's say find the conjugate of 3 plus 2. It becomes what? 3 minus 2. Okay, now back to this question. In taking the conjugate, I say what? Multiplied by what? The numerator and the denominator itself. You have your times here. 2 minus I. Because it's what? The conjugate of this denominator. Are you following? All over 2 minus I. Can choose to do it like this. Now, let's open this bracket. 3 times 2 gives you what? 6. Plus 3 times minus I gives you what? Sorry, gives you minus 3I. Plus 4 times 2 gives you what? 4I times 2 gives you what? 8I. Minus 4I times I gives you what? 4I squared. Are you following now? This is for the numerator. All over 2 times 2 gives you 4. Plus this 2 here times minus I gives you what? Minus 2I. Plus here. This I here times this 2 gives you what? 2I. Are you following now? Minus plus I times minus I gives you what? Minus I squared. Are you following now? Just split this bracket, you get something like this. Okay, now let's collect like terms. Let's collect like terms. What are your like terms here? If you look on the numerator, you see minus 3 and 8. How do you collect these like terms? Minus 3 plus 8 gives you what? Minus 5. Are you following now? Now it's 6 minus what? 5I minus 4I squared. All over. Let's take like terms here again. Minus 2I plus 2I gives you 0. There go. You'll be left with what? 4 minus I squared. But remember the law. I squared is equal to what? Minus 1. Wherever you see I squared, you put what? Minus 1. Now, 6 minus 5I minus 4 into what? Minus 1. All over 4 minus what? Minus 1. It's I squared. I squared means minus 1. This is a minus sign. Now, let's simplify. 6 here minus 4, 5I minus. Now, minus times minus gives you what? Plus. 4 times 1 gives you what? 4. All over. Now, minus times minus gives you plus. Your what? 4 and what? 1. Are you following now? Okay. Having something like this, what are you going to do? These are like terms also. Okay. Let's take or collect like terms here. In collecting of like terms, 5 here stands on its own. 6 and 4 are like terms because they don't have coefficient. Are you following now? So 6 plus 4 gives you what? 10 minus 5I. All over 4 here plus 1 gives you what? 5. Now, you can choose to leave your answer like this. But then in showing your answer in incantation form, you are going to see 10 over 5 minus what? 5, sorry, 10 minus 5 all over what? 5 minus I. And this becomes what? Your answer in incantation form. Are you following now?